Hey, we have the problem on the board, x to the 6th equals 6, and we need to find all solutions. I really tried to emphasize all there, so that we're not just finding the real solutions, we're going to find any real or complex solutions to this problem. To start with, what we'll do is we'll take this and we'll raise both sides to the 6th power. So we'll have x to the 6th raised to the 6th, and we'll have 6 to the 6th on the right. Just with exponent rules with parentheses here, we can multiply this inside. We'll rewrite this as x to the 6x to the 6th equals 6 to the 6th. But then the left side can be rewritten again as x to the 6th, like this, x to the 6th. And that allows us to equate exponent to exponent, base to base. And then we can say that x to the 6th equals 6. So now here's where it gets a little complicated. We normally would take the 6th root on both sides here, right? And we would end up with x equals the 6th root of 6th. And well, we're not quite done because really this would be positive or negative. You'll notice that a positive or negative 6th root of 6 will work in this. But going back to all solutions, we want to do all solutions. So let's do this a slightly different way. I know people do this different ways. This is the roots of unity. What we can do is, this is the way I like to do it. I know this is kind of different than from how you may have seen it, but I'm going to create a 1 right here. So right, 1 times 6 is still 6. So then we're going to rewrite it, but we're going to rewrite this 1 in the form from Euler's formula. So we're going to write the 1 as e to the I 2 pi n. Okay, so a brief aside, let's look at Euler's formula. So Euler's formula is e to the ix equals cosine x plus I sine of x. So then what we can do for our x, we can just plug in this 2 pi n piece. So when we look at e to the 2 pi n, this is the same thing as cosine 2 pi n plus I sine 2 pi n. But cosine of 2 pi n is 1, and sine of 2 pi n is 0. So long story short, this whole thing is just 1. So what we've done is we've just rewritten our 1 in this format, and that's going to help us with this. So let me get rid of this and we'll continue. So now you might be wondering, why did I do that? Well, we're going to take the 6th root now, and you'll see that by doing it this way, we can now get all of our solutions instead of when we did it before, we only got 2 solutions. So, okay, so now that we've rewritten our equation here, let's take the 6th root on both sides again. Let's split this up and do these separately. Okay, then here on the left, we're gonna have x equals, this is just gonna be, we'll just take our real part, 6th root of 6. Then what I'm going to do is let's rewrite this 6th root as 1 over 6. So we can rewrite this as e I 2 pi n over 6. But then we can cancel here. And we're going to have this side being the 6th root of 6 e I pi over 3n. So now that we have our nice formula for x, what we can do is we can start plugging in integer values for n from 0 to 5. We don't need to go past 5. If we plug in 6 or 8, whatever, the values are going to just start repeating because we know that values of sine and cosine just repeat, so we can stop at 5. So let's start with 0 here. So when we plug a 0 into this, the exponent will be 0, and so this piece will be 1, and so our x value is just going to be the 6th root of 6. And that's just the primary real solution that we found previously. Now next we can take our 1 for n, plug that in. We'll have the 6th root of 6 e to the I pi over 3. Then we can reduce this using Euler's formula. Then with Euler's formula, this is going to be the 6th root of 6 cosine pi over 3 plus I sine pi over 3. Cosine pi over 3 is 1/2. And then sine pi over 3 is square root of 3 over 2. So then I'm just going to clean this up a little bit. Doing the exact same thing, plugging in an n here. Okay, this is going to be the 6th root of 6 ei 2 pi over 3. Then if you use Euler's formula again for this, you'll see that this value is the 6th root of minus a half plus square root of 3 over 2i. Next, let's look at the case when n is 3. You'll notice the 3's will cancel and we're just left with ei pi here. So we're going to have the 6th root of 6 ei pi, but ei pi is just -1. If we look at Euler's formula for ei pi, we end up with cosine pi plus I sine pi. This piece is 0, but sine pi is 0. Cosine pi is -1. So this value is actually going to be minus the 6th root of 6, which is great because that's our second real solution that we found earlier. Repeating the same process for n equals 4 and n equals 5, we get our last two roots, our last two solutions. So we end up with 6 different solutions, right? 4 complex, 2 real solutions, and kind of cool. So you notice each of the complex solutions is they look the same, but they're all a little different because the sign changes. So we end up with our 6 solutions, and that's it. I have a bunch of similar problems in my quiz exponential tower challenge. I'll provide a link in the description. Those problems, I think I'm only looking for real solutions, maybe even positive real solutions. I can't remember. Also, I have a cheat sheet on the roots of unity, which is basically that's the process we use for finding all the roots. So it's kind of brief, but I have that, and I'll provide a link to that in the description. I'll stop it there. Hope that helped.